All right. Welcome to segments formed by tangents and secants, level 2. And it would help if I spelled level correctly. All right, so level 2. Now, in our very first example, this is a word problem, and it will most closely resemble example 6, just because I wanted to save some time in the video. So let's go ahead and get started with this problem that resembles example 6, and then our later problems will more closely resemble examples 1, 2, and so on and so forth. So, example 1 says this. We have a tangent, CD, so let's underline that word tangent, and a secant, CBE, so let's underline that word secant, and they meet at point C. Now we know that tangents and secants will always be some things that we apply to circles, so I will draw myself a circle, nice circle right there, and our point C is going to have to be somewhere on the outside. That's the only possible way to draw this scenario. And let's go back to our tangent. So we know it's tangent CD. So that means we're going to start at C. And remember, a tangent only touches a circle in how many places? What do you think? Correct. A tangent only touches a circle in one point. So let's go ahead and draw our tangent on the bottom this time, kind of switch it up. And my tangent line can go from point C to point D. Now then I want to look at my secant, and I know I have secant CBE, and let's see, if a tangent touches a circle in one point, then a secant must touch it in, awesome, 2 points, absolutely correct. And we know it goes C, then B, then E, so what I can do is draw my line, and our first letter, since it goes C, B, E, will have to be B, and our second letter is going to have to be E. Now let's fill in all the information that we're given. So let's see, it says CD is 14.2, so I come down to my tangent line, which is only touching the circle in one point D, and I'll write 14.2. And we know that CB is 8, so I'll come up here to CB and I'll write 8. And we want to find BD, so I can come over here to BE, and kind of different than our last video, I'm actually just going to put a question mark. And for these, it's a little bit different than our typical algebra, so I would like you to get in the habit of using a question mark. I think that'll be the easiest thing to do. Let's go ahead. I'm going to switch colors up just a little bit. And let's write out our statement. What do we know? If we look at our formula chart, we're talking about segments. That's that bottom row. And we know on our formula chart, we always look at our tangent, CD, and our tangent will always be squared, equals. And then we look at this line, and we know that for a secant, we're always doing the outside, which is CB. So it's always the external secant, the outside, times the whole. And that's what's going to make this a little bit different. When we're writing out our statement, we know that we have to go all the way from C to E. And so really and truly, when we set up this statement, we're actually not going to be able to directly find out what the inner secant is, the BE segment. But let's get to that. So we know CD, we know our tangent is 14.2, so I'll write 14.2, and we want to square that, equals. We know that CB, our external piece, is 8 times, and here's where we want to use an X, because we don't know what is the whole length of CE. Now going ahead and reaching for my calculator, because we should definitely use our calculator here, what is 14.2 squared? Or, conversely, what is 14.2 times 14.2? And that would actually give us 201.64 equals. And of course, we know 8 times x is simply 8x. Well, now we're one step away from getting our value x by itself. How should we do this? What do you think we should do? Of course, we should divide both sides by 8, our number in front of x. So I go back to my calculator. And 201.64 divided by 8 gives me x equals 25.2, and it says 0.5. Let's just round that to 2.1. Now here's the big question, and this is why we miss a lot of questions on our test. We have to ask ourselves, are we answering the question that's being asked? And our question is asking us to find BE. Well, when we look at x, x is the whole thing. X is the whole line C to E, but we don't know what BE is. Well, how are we going to find that? Well, if we know our whole line, let me kind of draw a box here. Our whole line is 25.21, and we know that this part right here, CB, is 8. Well, if we know the whole and we know a piece, we're simply going to do 25.21 minus 8. And what is 25.21 minus 8? Well, of course, that would give us 17.21. And in this case, that is the length of BE, 17.21. And remember, our units are inches. And there we go. Now go ahead and pause the video if you need to finish writing down these notes. But I'm going to go ahead and clear this, moving on to example 2. And let's go ahead and write out example 2. Now example 2, of course, is going to be a little bit of a shorthand. And let's make example 2 closely resemble problem 1. So let's see. So I just want you to find x. And I'm going to give y'all a picture that looks something like this. Remember, I'm going to use different numbers. Where it, once again, it looks like our secant is on top and our tangent is on the bottom. Let's use the same letters though. So we have D and we have C. And right here, let's use B and E. Okay. And this time, I'm going to put X right here. And I'm going to put, let's say 9 right there. And let's say 12 right there. And let's use our units in centimeters. Okay. So we want to find X given this scenario. Go ahead and switch colors here. Let's go to a nice turquoise. Okay. So, very first thing, we want to look at our formula chart. We want to identify this situation where we have a tangent and a secant. And when we look at it, we see that this one line, our tangent, is always going to be squared. So I'll write CD and parentheses squared equals. Now I go back up to my secant line, and when you're looking at your formula chart, what you should see is that you have the outside piece, which in this case would be CB, times the entire thing. And in this case, the entire thing goes all the way from C to E. So we write C, E. Now let's go ahead and fill in the things that we know. We know that CD, our tangent, is going to be x, so we'll simply write x squared equals. We know that CB, our external piece, is 9 times. However, and this is where people make a mistake. If you were to write 12, that would be incorrect. We know that the 12 is simply for CB, and so we're going to have to find this whole length. So here's my question to you. If we know that one piece is 9, we know this other piece is 12, well, what would that imply that the whole length is? Yeah, well, you would absolutely add them up. We'd have 12 plus 9, and we know that 12 plus 9 means the whole thing is 21 centimeters. So right over here, I'll write 9 times 21. Just to illustrate that, once again, we're now talking about the entire length. Okay, so let me switch back to my turquoise. And so now we have x squared equals, and we know that we want to do this 9 times 21. Once again, let me go ahead and reach for my calculator. Of course, my guess is 189, but we're all prone to make mistakes. So 9 times 21 is, oh, very good, 189. And now we just have to ask ourselves, if we have an x squared, how do we get rid of the square? Well, what is the opposite operation? The opposite operation of a square is to take the square root. Remember what we do on the left, we have to do on the right. And so a square root and a square, they cancel. And we're left with x equals, and let's see, what is the square root of 189? I reach for my calculator. And it appears to be 13.747, which rounds to 7.5. In this case, we would say our unit is centimeters. Now, have we answered the question that's being asked? Well, our question was asking us to find x, and we found x, so yeah, we're done. Awesome job. Alright, well, I hope this video helps, and I'll see y'all on our level 2 video.